continuing with the measurements of tool thickness. So, when we try to take a gear, so the thickness, the teeth, right. So, this is the thickness we have to measure. So, this is the, here is a pitch circle diameter, and here this is what we have to measure. So, measurement of the tooth span micrometer. So, there is a tooth span micrometer which is available. So, we will use that and try to figure out what is the tooth thickness. The tooth thickness is measured by measuring the caudal distance over a number of teeth, caudal distance over a number of teeth by using a tooth span micrometer, also called as flange micrometer. So, here we try to measure the caudal distance over a number of teeth. It is not a single teeth. We are trying to take it, it's like almost averaging. So, but what we do is, suppose we do 1, 2, 3, 4 teeth. Next time what we do is we do 2, 3, 4, 5 teeth. So, then it is 3, 4, 5, something like this. So, you keep increasing and going, so that you try to get to measure 3 or 4, whatever it is, you keep measuring that. So, that is what we said, caudal distance over a number of teeth by using a tooth span micrometer, which is otherwise called as flange micrometer. The measurement is based on the base tangent method. So, base tangent method, so here what we do is we try to take, okay, this is the center line. So, we try to take a tangent, a caudal, which is A, B and C. Next one is going to be A1, B1 and C1. Next is going to be A2, this is B2 and then chord, right. So, then it will be C2. So, how do we use the measurement with the tooth span micrometer? We try to take A and C, we wanted to measure. So, that is equal to, so AC, right, pitch circle diameter, AC is equal to what, if you go back to that figure, it is back A1 C2, A2 C1, A0 C0. So, all these things are nothing but the AC what we are trying to measure. So, for T number of teeth called the tooth span, then AC is equal to T minus half the pitch. T is the number of teeth, half the pitch. Then the angle subtended by AC, right, is nothing but half minus T into 2 pi by n radians. So, the involute function of pressure angle phi or del is nothing but tan F by minus F, where F is the pressure angle. Okay. This will be in given. So, note F will be in angle pi, okay. F is given. So, involute function of the pressure angle del is equal to tan F minus F. So, F is a pressure angle. Therefore, the arc BD is nothing but T minus half into 2 pi radians plus the pressure angle which is subtended. So, BD is nothing but the angle by the arc BD into RB, where RB is the radius of the base circle. Okay. With this, what we try to do is we try to find out what is BD, AC we found out, then we are finding out BD. Further continuing with the same, BD is equal to the angle subtended by the arc BD into RB, with RB is the base angle. So, thus BD can be figured out as S. So, this S you can replace it by, where S equal to, you can replace it by T. So, T minus half 2 pi by n plus 2 tan phi minus phi, where phi is the pressure angle. Okay, Rp by cos phi, where Rb is the radius of the base circle, which is nothing but Rp into cos phi. Okay, so, when you try to put it back into the equation, you have module n by 2, then all the other units you know. Therefore, the arc length BD, is nothing but n into m cos phi pi s minus n by pi minus 2 pi and this is the final equation to find out the arc of BD. Okay. This is the del which we were discussing about. Del is the involute function of the pressure angle, where phi is the pressure angle. Okay. So, this Amandeep correction karna hai. So, del is the involute function of a pressure angle that can be figured out as tan phi minus phi. So, this is nothing but it can be written as del equal to tan phi minus phi, right, where phi is in angle, right. Let us try to take a problem and try to solve this. A tooth span micrometer is being used to measure the span across 3 teeth. We have given T3 teeth. 3 trials are conducted and the average value of the span is 31.120 millimeter. The following data is available for the gear being inspected. The number of teeth is 32, addendum circle diameter is 136, pressure angle is given as 20, the span of measurement is 3, and then determine the percentage error of measurement. So, theoretical span width for 3 teeth is equal to n m cos phi by pi s n minus s by 2 n plus tan phi minus phi. Okay. Now, let us write down n equal to number of teeth. Small m is nothing but the module. Okay. S is the span and phi is the pressure angle. Right. So, m equal to, how do I find out m? M is nothing but addendum circle diameter divided by z plus 2, right. So, this is nothing but addendum diameter is 136 divided by z is number of teeth 32 plus 2. So, this is nothing but module is 4. Okay. Therefore, the span of W3T is nothing but 32 into 4. Okay. So, here this Z and N are same. N number of teeth, Z is also number of teeth. Okay. So, 32 4 into pressure angle cos 20 degrees pi 3 s divided by 32 minus pi 2 into 32, and then it is plus tan 20 minus pi by 9. Okay. This is nothing but 31.314 millimeter. So, the error is going to be 31.314 minus 31.120, which is 0.194 millimeter. So, now the percentage error is going to be 0.194 divided by 31.314, which is equal to 0.006 percentage. So, this will be the percentage error which is to be solved this problem. So, how do we use this? So, this is done by tooth span micrometer, which is used to measure the error. Okay, tooth span micrometer. If you look at it, the composite method of gear inspection is done by Parkinson's gear tester. This is how is a gear testing done. You have a lens to view, and then you have a you have dial gauges to measure the deviations, right, and then 2 gears you have, so you can measure it and see. So, the gear being inspected will be made to mesh. Master gear, this is the gear to be inspected. These 2 gears will mesh with a standard gear, and a dial indicator is used to capture the radial error. Okay. This is used to capture the radial error. The 2 gears are mounted on mandrel. This is a mandrel which facilitates accurate mounting of the gear in the machine, so that the dial indicator will primarily measure the irregularities in the gear under inspection. The dial indicator of high resolution is used to measure the composite error, which reflects the error due to run out, tooth to tooth spacing and profile variation. That is why it is called as composite method of gear inspection. We will measure run out, we saw these are the errors, then tooth to tooth variation, tooth to tooth spacing and profile variation. So, this can be easily monitored through this composite gear inspection device. So, this is otherwise called as Parkinson's gear tester. So, to recap what all we have seen in this particular chapter, we first saw gear, various types of gear, then gear terminologies, what are the different types of spur gear errors, where we saw run out. Okay. So, the spur gear, why spur gear? Because it is the most simplest gear, and if we understand here, for the other gears it will be a small variation. For example, helix, the teeth will be at an angle. Then various methods of measuring gear elements we saw. Gear profile can be measured. So, gear pressure we can also use for measuring the profile. We can use a profile projector. Profile projector can also be used, which is one of the comparator technique. The gear will be kept on top of a glass plate, and then the light from the bottom, the light will be projected. Then you will have lenses. So, with these lenses you can project it on top of a screen, and in that screen it will be magnified according to a requirement. Then you have a master, you can place it on top of the shadow whatever comes and try to see the variation. So, here you can try to measure the thickness, you can try to measure the involute profile, many things. So, that is one of the comparative technique which is used to measure the profile, then measuring of tooth thickness, then composite gear inspection. Then we also saw about the Parkinson's gear tester. Okay, composite is where 2 or 3 errors are measured together and then we do it. Okay. Task for students. So, here what we do is, let us try to take a mechanical setup where there is gear meshing. Okay. Now, what I want you is, I want you to replace this gear meshing. Please replace the gear meshing by any means and try to see the performance of the mechanical setup. Okay. Next is, so we have seen, I would like you to see the rear wheel axle of an automobile, that means to say a truck or a truck, and understand why the 2 gear axes do not meet, or what is the function of non-meeting. So, this you can browse through and get to see, or if you can physically see, that is also encouraged. Third thing is this, the herringbone, you have gears like this herringbone. So, can you find out some application? Some application means minimum 5 of its usage in real time. And the last one is, in the printers they use gears. These gears do not have major wear in spite of continuous working. How is this happening? Okay. So, these are the 5 things which are 4 things which are attached to gear. So, please look into those gears, and then it will also be a good idea if you can write down types and number of gears used in a printer. With this, you can try to have a feel what is gear, what is the importance of gear, how complex is the gear profile, where are its application. Okay. Thank you very much.